So we are discussing about the Galileo's law of odd numbers. So what he suggested, in an equal interval of time, when the body is free falling, it covers the distances which are in the ratio of odd numbers starting from the unity. Okay, in first time it will, if it travels 1 meter, then it will travel 3 meter, then it will travel 5 meter, like that. So that we have discussed. So what he has suggested, the distance travel in t1 is to distance travel in second time interval, that is ts2. Sorry, st2 is to st3 is in ratio of 1 is to 3 is to 5, so on, like that. So this is what the Galileo's law of odd numbers. Okay. So, and he has also suggested about the one more experiment he has done. He stand on some, what is that, the tower of Pisa. So what is, he stand here and he thrown 2 balls over here, from here. Okay. So he counted whether they will reach at the same time or a different time, irrespective of their masses. Okay. Suppose if you take one heavy mass and one light mass, you take one iron ball and you take one plastic ball over there, and neglecting air resistance. Okay. Neglecting air resistance. So what will happen? Both will reach at the same time. Okay. So what usually we thought, the ball which is having the more mass will move faster, and which is having the less mass will move slower. But when they did the experiment, both are reaching at the same time. Okay. Why that is happening? So because value of g is what, 9.8 meter per second square. Okay. This is a constant value on the surface of Earth. Okay. So that is why if the force of attraction from the ground is what, F equals to m into g. Okay. To maintain g constant, F divided by m. So since m is more means, so what will happen? The earth will attract it with the more force. Okay. Here m is less means the earth will attract it with the less force. So what is the intention of surface of earth? To maintain this constant. Okay. So if this acceleration or the rate of change of acceleration is constant, means what? What will happen? It is moving with the same velocity, same increasing velocity. Okay. So that is what, for this also it is 9.8, for this also it is 9.8. That means both are increasing their velocities in a equal value. Okay. So that is why both will reach at the same time. Okay, irrespective of their masses. Okay. So irrespective of their masses, they will reach ground at same time. So what is the reason? Reason is to maintain 9.8 constant for both. So that is why Earth will attract the heavy body with a larger force and lighter body with a lesser force. Okay. So that you must have studied in your high school. So no need to spend much time on that one. So one more very important thing for your board exam is concerned, that is what? Reaction time. What is that? Reaction time. So what is this reaction time? Okay. Suppose you are driving the vehicle. All of a sudden, someone will come in your way. So as soon as he comes, you have to apply force on your brake. But it will take some time. What is that time? You will see that person, you will observe that, then you have to think, then you have to act. Okay, to send the message from there to your legs, it will take a amount of time. Okay, so that amount of time is what? Reaction time. So what is this reaction time? The time taken to observe, then think and act. Time taken to observe, think and act is called what? Is called reaction time. Okay, so reaction time. Okay, so this is what the reaction time. Suppose if I drop something from here, so when the message sent to your brain, you have to think what type of action I have to take. So suddenly you will say to your right hand, so please hold it. So this much the sending, observing, and then thinking, then acting. So that will take some amount of time. That amount is called as what? Reaction time. Okay, in your NCERT book they are given a wonderful example. They have taken a scale or something. So what they are doing, they hold this scale. So if another person holding this one, and you have to you just hold another hand of you here. So then if you drop it, so as soon as if you drop it, what will happen? The message will go from your left hand to your brain, then your brain will think what the right hand to do, then it will send message to right hand, then right hand will hold it. Okay, so for that it will take time. Okay, so now here I am not holding, but here I am holding. As soon as I leave it, both are your hands only. Okay, so you are very much concentrated on that only. Then also, as soon as you leave it, so what will happen? Your hand is holding, but this much distance is already traveling. Okay, your action is very much quick, but already this much distance is traveled. Okay, so for this to travel this much distance, time is required. So that time elapsed to travel this much distance is called as what? Reaction time. Okay, so how much distance it has traveled? It has traveled, say, some 10 centimeters. Okay, so if you are alone doing experiment, you cannot observe much. So you may observe the little distance, but experiment should be done with what? 2 people. Okay, so one person will leave it and another person has to hold it. So then it will travel a much distance. Okay, so that is what we call it as the reaction time. So how we can do this one? If suppose this distance, if I take it as the d, so what will happen? So if you take a scale and one person is leaving from here. Okay, so one person is leaving from here and another person is holding it. Okay, so how much distance it traveled? It traveled the distance d. What is the initial velocity? Initial velocity is 0 because it was at rest. So now you can apply s equals to ut plus half gt square. Since it is traveling in downward direction, we have to take plus sign. So what will happen? S is what? Distance traveled is d. So d equals to u is 0, so this is going to be 0. So what remains is half gp square. Okay, so take this 2 on this side, g to numerator. So t square equals to what? 2d divided by g. 2d divided by g. So t equals to what? T equals to root of 2d divided by g. This is what the reaction time. This is what reaction time. Okay, so reaction time formula is what? Root of 2d divided by g. Okay, if we take some example, for example, suppose it travels, say, some 20 centimeter of distance. Suppose it travels some 20 centimeter of distance. So what is the reaction time? T equals to root of 2d divided by z. So 2 into 20, it is in centimeter, you have to convert into meters. So into 10 to power what? Minus 2. So into 10 to power minus 2 divided by g. G is actually what? 9.8, but for calculation purpose I will take it as 10. So right here 10. So this 0 will get cancelled. So 4 into 10 to power minus 2. So root of 4 is what? 2. Root of 10 to power minus 2 is what? 10 to power minus 1. So 0.2 second. So reaction time is what? 0.2 second if it travel 20 centimeter. Okay, so if it travel 2 centimeter, if it travel 10 centimeter, so 10 will get cancelled. So root 2 into 10 to power minus 1 will be your answer. Okay, so it depends. So what you have to remember here is you should explain the experiment. Just hold the scale, one person will leave it at some instant of time, so another person has to hold, but before that what will happen? The scale will travel some distance, so take that distance as d and derive the formula. They may ask for 3 marks, that much, only 3 marks, so they may ask only definition and formula for 2 marks also. So totally for the board exam purpose. Okay, so remember the definition, what is reaction time. Okay, so one more very important concept, that is what usually you can see in your daily life, so that is stopping distance. Okay, so what do we mean by stopping distance? Okay, suppose a vehicle is traveling. Okay, so suppose a vehicle is traveling. So now you will apply the brake. Okay, you will apply the brake. As soon as you apply the brake, suppose it is traveling with say some velocity u. Okay, it is traveling with some initial velocity u. So as soon as you apply the brake, it will not stop. It will not stop here. It will not stop here. What will happen? It will travel some distance. So what will happen? Its velocity will go on decreasing. Then it comes to rest over here. Okay. So here it comes to rest. So here it will stop. Where you apply the brake, you apply the brake here only. But your car is coming to stop at this point. Okay. So before coming to rest, it has traveled some distance. Okay, so this distance is called as stopping distance. This distance is called as stopping distance. Okay, then how we can define this one? So when brake is applied, when brake is applied to a vehicle, it travel or a vehicle, then the distance traveled by it before coming to rest. Okay, so when brake is applied to a vehicle, then the distance traveled by it before it coming to rest is called as what? Is called as your stopping distance. Okay, so when the vehicle is moving, you will apply some brake. So after applying the brake, so how much distance it will travel before coming to rest, that distance is called as what? That distance is called as stopping distance. It's very important. If you don't know about the stopping distance, so if you want to stop somewhere here, if there is a wall in front of you, suppose there is a wall in front of you and your vehicle is here. Okay, so if you apply the brake here, it may comes to rest and it may stop over here. Suppose instead of applying brake here, if you apply brake here, what will happen? It will, even though you apply the brake, so what will happen? Your car will not stop. So what will happen? It will hit the wall. Okay, so it is very important. This is a very important concept in your in the trains. So if your train is here, so what will happen if station is going to be here? So he will apply brake here only. He will apply brake here only. So where that person should apply the brake should be what? Predefined. He has to know this distance. If this is the station, if he apply the brake here, then it will come and stop here. Okay, so this is what he should know, what is the stopping distance for that vehicle. If he, instead of applying here, if you apply the brake over here, what will happen? So train will go somewhere here. So train will stop after the station. Okay, so that should not happen. That should not happen means what? The person who is there in the train, he should know what? He should know stopping distance of that train. Okay, that is why it is very important. The people who are in the train or who are piloting the train, they should know the what? They should know the stopping distance. Okay, so this is the key factor in the trains mainly. So you must observe that one. So how we can calculate that one? Okay. So what is happening? It is your vehicle. Your vehicle is going with some velocity u. So here what will happen? Here it will come to rest. Okay. So rest means final velocity is 0. Initial velocity you can take it as u. So stopping distance, how we can calculate? We can calculate, this is what the stopping distance. So what I can write, can I write it as ds, stopping distance, or sd, whatever you can write. So apply v square equals to u square plus 2as. Okay, so v is what? V is 0, u you can take it as u only, so s is what? You can take it as ds, stopping distance, or sd. So 0 equals to u square plus 2a ds. Very important. What about the a? Here what is happening? It was moving with some velocity. When you apply the brake, what is happening? Velocity is decreasing. Okay, velocity is decreasing means what? Acceleration decreasing. When acceleration is decreasing, that is called as what? Retardation. This is what? Retardation. So here what will happen? It will retard. If it retards, so acceleration you have to take it as what? You have to take it negative. Okay, so take a as negative. A equals to what? Minus a. So what will happen? 0 equals to u square minus 2a ds. Okay, so send u on this side. Minus u square equals to minus 2a ds. Okay, minus minus will get cancelled. So ds equals to, stopping distance is equals to u square divided by 2a. U square divided by 2a. So this is what formula for stopping distance. Okay, this is the formula for what? This is the formula for stopping distance. So stopping distance is equals to u square divided by 2a. Remember, a is what? A is a retardation. Okay, so remember what exactly stopping distance is. This will help in our day-to-day life. Okay. Next, very important for your competitive exam also. So that is what? Relative velocity. Relative velocity. Okay. So I am not going to make it much complicated as given in your NCERT or something. Very simple. You must observe this relative velocity in your day-to-day life. Suppose you are sitting in the bus. Which is in the bus stop. Okay, so beside you another bus is also there. So suppose if that bus is started moving, so what do you think, that your bus is moving in backward direction, or if that bus is moving in reverse direction, you think that your bus is moving forward, but in reality your bus is at rest. Okay, or if you are traveling in one bus, another bus is also coming and it is traveling with a velocity lesser than you, then what you feel that is moving in backward direction. Okay, but it is not like that. It is also moving in forward. Okay, or if you are sitting in the bus, so outside trees and whatever the things are moving in backward direction, that is what you are feeling. That is the velocity of those objects with respect to you. Okay, so these are what the examples for relative velocity. Suppose you are sitting in the train and another person is also sitting in the train. You think that person is at rest. So relative velocity of that person with respect to you is what? It is 0. That means he is not moving only. But in reality, for the outside person, that person has some velocity. Okay. So these are depends on the observer. Okay. So relative velocity depends on you and where you are standing. Okay. So we will see what exactly the relative velocity is. Suppose this is the origin, and how we can define? You can define it as in simple way. So velocity of an object with respect to another object. Okay, so velocity of an object with respect to another object is called as what? Is called as relative velocity. Okay, so now if I take some reference point origin here, so one object is standing over here. So you can take one vehicle over here. Say it is A, and another you can take it here. Okay, so this is what vehicle B. Okay, so this is moving with, say, velocity VA, and this is moving with velocity VB. Okay, So its position from origin is what? XA, and its position from origin what? XB. Okay. Now, so can you write XA as, say it has taken time t to come here, and it is also taken time t because it is moving with some higher speed. Okay. So can I write? We know that velocity equals to what? Distance divided by time. So distance is what? Distance is velocity into time. So this distance, can I write it as velocity of A into time? Similarly, this distance of B, I can write it as xb equals to velocity of B into time. Okay. So now, this is what Vb is what? Velocity of vehicle B with reference to origin. With respect to origin, VA is what? Velocity with respect to what? With respect to origin. Now what I want? I want velocity of B with respect to A. So for velocity of B with respect to O is what? XB divided by T. But with respect to A is what? This distance divided by time. So this distance you have to find. So how we can find this distance? XB minus XA. XB minus XA will give what? This distance. So XB minus XA is equals to PBT minus PAT. So take T outside. XB minus XA is equals to, so PB minus VA into T. So XB minus XA. XB minus XA is what? Distance between these two, or displacement between A and B. So time will come here. So T equals to PB minus PA. Okay. So what is this XB minus XA? It is a displacement of B from A. Displacement of B from A. So this displacement divided by time will give what? Velocity. That is what? Velocity of B with respect to A, not with respect to origin. Getting the point? This is the distance. This is the distance from A. So, well, this distance divided by time will give what? Velocity of B with respect to A, not with respect to O. So, what I can write here is velocity of B with respect to A, or velocity of B relative to A is what? PB minus VE. This is what the relative velocity. Okay. So, can I write velocity of B relative to A is PBA equals to PB minus VA, or velocity of A relative to B is what? PAB is equals to PA minus VB. So anything you can take. What they are asking is important. If they are asking relative velocity of B with respect to A, it is VB minus PA. So if they are asking relative velocity of A with respect to B, it will be reverse, VA minus VB. Okay. So these are the what formulas for relative velocity of one object with respect to another object. But while writing these formulas, we should be very much careful about what they are talking and about what respect they are talking. Okay. Here they are telling about with respect to A, relative to A, so A will come later. Here they are saying relative to B, so B will come later. Okay. So these are the what simple formulas for the relative velocities. Okay. Relative velocity of B with respect to A is what? PB minus V. Okay. Suppose you are having a say one vehicle here, say of A and another is here B. Okay. If both are moving with the same velocity, what will happen? VA is equals to VB. If a person standing here, so for this person he is at rest because both are moving at the same time. You think that this is at rest, it is also coming with you. Okay. So that is why. So relative velocity of A with respect to B or B with respect to A. So what will happen? It seems to be 0. Okay. So that is why PB minus VA is 0. So what you will get? PA equals to PB. So whenever both are moving with the same velocity, so what will happen? The relative velocity will become 0. That means you will feel that that person is at rest or that vehicle is at rest. Okay. So if instead of that one, if I go for second case, if A is here and B is here, it is moving with velocity VB and this is moving with velocity VA, but situation is VB greater than VA, VB greater than VA. So if VB greater than VA, after some time what will happen? Your B will come here, your B will come little farther. So PB minus VA, VBA equals to PB minus VA is positive or negative? It is positive. So it is positive means you will feel that B is moving forward. Obviously, if another vehicle is moving a little fast, so what will happen? You will feel that is moving faster. Okay. So what will happen? PB is greater than VA, so you will get velocity of B with respect to A is what? Positive. That means you are going farther. Okay. So instead of that one. So A is moving with velocity VA and B is moving with velocity PB. Situation is PA is greater than VB. Okay. Now what will happen? PA will come here. So your VB is you are feeling that you are going in reverse direction. So VBA will what? VBA is VB minus VA. PA is greater than VB. So what will happen? You will get it as negative. Negative that you feel that you are going in reverse direction. You will feel that you are going in backward direction. Actually what is happening? That is moving faster in forward direction. But as a person you are sitting in vehicle B, you feel that you are moving in reverse direction. So that is why your relative velocity will come as what? Your relative velocity will come as negative. Okay. So these three situations you have to remember. When VA is equals to VB, when VA is greater than, VB is greater than VA and PA is greater than PB. Okay. So now if we thought of plotting the graphs also, suppose this is the origin. PA is here and B is here. Okay. So these are the what positions? Say this is at some x A and this is what x B. Okay. Now if it is moving with VA velocity and this is moving with what? PB velocity. Okay. If VA equals to VB, PA equals to PB. After some time what will happen? Your A will come here, B will come here. Okay. But this distance is remains same only. Why? Because it is also moving 10 meter in 1 second. This is also moving 10 meter in 1 second. In 1 second this object comes here. In 1 second this object comes here. Both have traveled what? Both have traveled 10 meter. If both are traveling 10 meter means this distance, if suppose here it is 5. So this 5 is going to be constant. Here also it is going to be what? Here also that is going to be 5 only. Here also 5. That means the distance between two vehicles is not changed. Okay. Suppose if I plot the graph, this I will take it as position and this I will take it as time. Okay. So position, time, graph. So first A is here, position XA. So B is here, XB distance. Okay. From here it is XB, from here it is XA. What will happen? Both are moving the same velocity. So displacement or position is going to change. Okay. So if you calculate at any place, slope of position time will give you what? It will give you velocity. So velocity is going to be remain same. Okay. And here what is the distance? 5. If you calculate here, it is 5. If you calculate here, it is 5. Means distance between A and B is what remains constant. Okay. So that is why when VA is equals to VB, this is what the graph. This is what VB and this is what will give you VA. So this graph is for what? VA equals to PB. This graph is for PA equals to PB. Okay. Okay. Now suppose vehicle A is here and B is here, or you can take A is here and B is here. So this is what moving with VA and this is what VB and this is what moving with VA. Okay. This is what the origin. So now if you want to plot the graph for the situation VB is greater than VA, VB is greater than VA. If VB is greater than VA, if A travels say 5, B will travel what? B will travel 10. Okay. If distance between here is 10, now what will happen? This has traveled 5, but this has traveled 10. So what will happen? This distance between these two will become what? Will become 15 now. Okay. Or it will increase. Okay. So this is what the distance between A and B is what? A and B go on increasing. Why? Because A is moving with very high speed and B is moving with very high speed. A is moving slowly. So as it is moving high speed, it keep on going away from A only. B is keep on moving away from A only. So distance between A and B, what? A and B go on increasing. Okay. So if I plot that graph, so where is B? B is far away from origin. This is origin. So this is what your B, and I will take here it as A. A I will take here. Okay. So this is what position means X. Okay. This is what X position. So this is what time. So B velocity is more. B velocity more means like this. So velocity should go on increasing. Okay. So this is what the velocity of B. You can take it like this. Okay. So what about A? A velocity is increasing slowly. Change in position is very rate of change position is what? Very slow. So it will go like this. Okay. So now what will happen? Now what will happen? If you look at distance between A and B is less here. Here it is more. Here it is more. Okay. So this is what object A. So VB. So this is what VA. So what is happening here? Distance between A and B is what? A and B is increasing because B is moving far away from it because its velocity is more. Okay. If the same situation, if I play for VB is less than VA. Okay. That means VA is moving faster. Okay. Or you can write VA is greater than VB. Okay. Here VB was greater than VA. Now VA is greater than VB. Suppose this is the origin and your point A is here and B is here. Okay. So VA is greater than VB. So this is what VB. It is moving faster than B. A is moving faster than B. So B is moving slowly. So A will come and then this will overtake and it will go forward. Okay. So if you plot the graph of position versus time, if you plot the graph of position versus time, what will happen? So where is A? A is here at XA distance. Okay. So A I will take here at XA distance. Okay. So A I will take here at XA distance. Where is B? B is here. Far away from O. So far away from O. From O it is here. So this is what the B. Okay. So XB. Now B is moving slowly. So its velocity is less. So it is moving slowly. What about A? A is moving faster. So its distance from origin go on increasing. Then what will happen? This will come and that will overtake the B. So then it will go forward, but B is still near only. Okay. So that is why the position go on increasing. So at some point, what will happen? It will reach the B. Again, it will go forward. So what will happen? Your B will go here. Okay. So your A will come here. So this is what and this is what B. So this is what the graph when VB is less than VA or VA is greater than VB. Okay. So if you plot it properly, this is what the graph. Okay. So these are the few examples. So as we know, the relative velocity of B with respect to A or velocity of B relative to A is what? VB minus VA. Okay. So just I will change the situation. Suppose one vehicle is moving in this direction and another vehicle is moving in this direction. Okay. So if this is the situation, if direction of motion of vehicles is opposite, okay. So if this is situation, this is what moving with, you can take this as A and this as B, and here is origin, okay. This is what the origin, okay. So this is there at a distance of XA and this is there at a distance of XB, okay. So this is what the velocity of A, that is VA, and this is what the velocity VB, okay. So if this is the situation, so what will happen? V velocity of B with respect to A is what? Velocity of what you can take? You can take if I want to write what is velocity of A with respect to B. If I want to write velocity of A with respect to B, what I can write? Velocity of A minus velocity of B, okay. B with respect to A is what? VB minus VA. Velocity of A with respect to B is what? VA minus VB, okay. But here situation is VA is in this direction, so you can take it as positive, but VB is in opposite direction. So this VB I have to take negative if direction is opposite to the initial one. So VAB will become what? VAB will become VA minus of minus VB, okay. VB is negative, so you can write it as VA plus VB, okay. So this is what the relative velocity of A with respect to B, that is going to be VA plus VB, or relative velocity of B with respect to A is also going to be what? It is also going to be what? VB plus VA or VB plus VA plus VB, okay. So if this is the situation, if you want to plot the graph of position versus time, this is what X position and this is what time, okay. Now where is VA? A is there at a distance XA, only this much. B is there at a distance of XB, very high. This is what your B and this is what your A. So this is what XB and this is what XA, okay. Now see here, from O, A is going in forward direction, so this XA go on increasing, XA go on increasing, so XA go on increasing, okay. So what about B? B is coming towards O, that means XB is decreasing, so position is coming to its original reference point, okay. So this go on decreasing, okay. That means somewhere they will meet each other, so A will go on that side and B will come on this side. So same thing is happening. Distance of A from the origin go on increasing, distance of B from the origin go on decreasing, and at some point they will meet each other, okay. So this is what? This is going to be A, this is going to be B. If you take the slope, so VA and VB you will get. So this is what when the two bodies are moving in opposite direction, okay. Okay, so we can write heading also, okay. So when two bodies are moving in opposite direction, when A and B are moving in opposite direction, okay. So in opposite direction. So relative velocity is what? VA plus VB, okay. So this is what all about the relative velocity. So we will